Our final project for ES50 was building a smart mirror. When thinking of our project, we wanted to use what we had learned in ES50 to make one part of our everyday routine more efficient, and eventually decided on the mirror. Even in our busy schedules, we always spend some time in front of a mirror, whether that be when washing our hands or brushing our teeth. What if we could derive more utility out of these periods of time? Our final smart mirror does just that, providing two additional features over a normal mirror. It gives a real-time weather update and tells a random joke. We wanted to make this mirror as efficient as possible, so we also made it activate when detecting motion, as opposed to using a button or switch. We also built this mirror with minimalism in mind. As you can see, apart from the small sensor in the front, we were able to hide all of the circuitry needed to make this work. Now, let's start with a demo of our project. As mentioned earlier, all we need to do is wave our hand in front of the infrared sensor in order to turn on the mirror. This in turn causes the small OLED displays at the top right of the mirror to turn on, displaying the weather and a random joke. As you can see here, the weather is in real time as well. So, how does the circuit work? There are three main parts: the OLEDs, the two Arduinos with Wi-Fi enabled, and the sensor circuit. The operating flow of the circuit is as follows. When someone waves their hand in front of the sensor, the voltage passed into the op-amp comparator changes, causing the op-amp to output voltage, which is then detected by the Arduino Uno. Once this trigger is detected, the Arduino uses the Wi-Fi shield to make an API request to fetch the relevant weather and joke information, which is then parsed in Arduino code. Lastly, this parsed output is displayed on the OLED screens. Now, let's talk about the specifics of our mirror's functionality, starting with the sensor and comparator circuit. There are three main components of this circuit: a light-dependent resistor, an op-amp, and a voltage divider. The op-amp outputs a voltage if the input voltage, depending on the amount of light hitting the resistor, exceeds the output of the voltage divider. This output triggers the analog input pins of the Arduino, which begins the next step of this flow. Assembling the Arduino, Wi-Fi shield, and OLEDs is relatively straightforward, just requiring some careful soldering. The Wi-Fi shield sits perfectly on top of the Arduino Uno, making that part of the construction trivial. Lastly, let's talk about the code. We wrote several hundred lines of code in order to make API requests to external URLs and parse their responses to show on the OLEDs. A problem we faced when implementing this was the extremely tight storage space capacities of the Arduino, with only 2 kilobytes of RAM. To save space, we had to implement character-by-character parsing of the API responses. With all of the components built as described, we assembled them together into an initial prototype, one that worked but was very far away from our goal of a minimal design. To finish our project, we first had to build the actual mirror. Instead of using an actual two-way mirror, we used a two-way reflective film adhered onto a clear plexiglass acrylic sheet. The result was a lot more complicated than we had expected. However, the end result was quite good, with very few air bubbles. Finally, we used Velcro strips and masking tape to back all of the circuitry to the back of the mirror, with the exception of the IR sensor, which we attached to the bottom corner at the front of the mirror. With that, our smart mirror was done.